Hello friends, I am Meghnapari and today we are here to start the lecture series of the Mathematics 1. We are taking our today topic as the application of the partial derivative of the Lagrange multipliers. In last lecture we have discussed about the extreme values, find the maxima and minima of the functions. Now, today we are taking Lagrange multiplier method. What is Lagrange multiplier method? If f of xyz be a function of the three variables and the variables are connected by the relation phi xyz equal to 0, then we wish find the value of xyz for which f of xy is extreme, then Lagrange multiplier method will be used. Working rule for the Lagrange multiplier method: find auxiliary equation. Auxiliary equation is u equal to function f of xy0 plus lambda phi of xyz as equation 1. Differentiate equation with partially with respect to xyz. We getting del by del x, del by del y and del by del z, that is equation 2. For the extreme value, take del by del x equal to 0, del by del y equal to 0, del by del z equal to 0, and eliminating lambda from the above equation, we get xy and z are obtained for which f of xy has extreme values. This method of obtaining stationary value of the f of xy is called Lagrange method of undetermined multipliers. Equation 2 are called the Lagrange equation. Then term lambda is called undetermined multipliers. Now we are taking examples. Find minimum value of x square y z cube subject to the condition 2x plus y plus 3z equal to a. So what is our function? Function is x square y z cube and condition is 2x plus y plus 3z equal to a. Now take the solution. F of x y z, x square y z cube and 2x plus y 3z equal to a. It is our equation 2. That means phi of x y z is 2x plus y plus 3z minus a. Put is in the auxiliary equation. So u equal to x square y z cube plus lambda 2x plus y plus 3z minus a. It is our equation 3. Differentiate equation 3 partially with respect to x, y, z respectively. So del by del x is 2xy z cube plus 2 lambda. Del by del y is x square z cube plus lambda. And del by del z is 3x square yz square plus 3 lambda. For extreme values, 2xyz cube plus 2 lambda equal to 0. So lambda is minus xyz cube. It is equation 4. X square z cube plus lambda equal to 0. So lambda equal to minus x square z cube, equation 5. And x square yz square plus 3 lambda equal to 0. So lambda equal to minus x square yz square. It is 6. We are getting 4, 5 and 6 equation using del by del x equal to 0, del by del y equal to 0 and del by del z equal to 0. In that equation we are converting as a lambda as a subject. So we get equation number 4, 5 and 6. From the equation 4, 5, 6 we are equating them. Minus xyz cube equal to minus x square z cube equal to minus x square yz square. So what is yz equal to xz equal to xy. So yz equal to xz and xz equal to xy. So y equal to x and z equal to y. That means x equal to y equal to z equal to k. If x equal to k, y equal to k and z equal to k, substitute this equation in the condition 2x plus 5 plus 3z equal to a. Then k equal to a by 6. We get x equal to a by 6, y equal to a by 6 and z equal to a by 6. So what is our maximum value of the function? Put x equal to a by 6, y equal to a by 6 and z equal to a by 6 in the function. We get a by 6 raised to 6. Find minimum distance from the origin to the plane 3x plus 2y plus z equal to 12. Then xyz be a point on the plane 3x plus 2y plus z equal to 12. So distance d between xyz and origin 0, 0, 0 is d under root x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square is the formula of the distance between 2 points. So what is our d? It is under root x square plus y square plus z square. So d square is x square plus y square plus z square. So what is our function? Function is b square equal to x square plus y square plus z square. Now condition is 3x plus 2y plus z equal to 12. And auxiliary equation we get x square plus y square plus z square plus lambda 3x plus 2y plus z minus 12 is equation 3. This is our auxiliary equation. Now next step, find differential equation of the equation 3 partially with respect to x, y, z. So del u by del x 2x 3 lambda. We getting del u by del y equal to 2y plus 2 lambda and del u by del z equal to 2z plus lambda. For the extreme value, solve these equations. 2x plus 3y equal to 0. So lambda equal to minus 2x by 3, that is our equation 4. 2x plus 2 lambda equal to 0. So lambda equal to minus 5, it is equation 5. 2z plus lambda equal to 0. So lambda equal to minus 2z, it is equation 6. From the equating 4, 5 and 6, we getting minus 2x by 3 equal to minus y equal to minus 2z. 2x by 3 equal to y plus 2z equal to k. So x equal to 3k by 2, y equal to k and z equal to k by 2 is a point of the equation. Substituting in the condition 3x plus 2y plus z equal to 12, we get 9k by 2 plus 2k plus k by 2 equal to 12. So 9k plus 4k plus k by 2 equal to 12. 4k by 2 equal to 12. So k equal to 12 by 7. If we are taking x equal to 3k by 2 and put the value of k equal to 12 by 7, then x equal to 18 by 7, y equal to 12 by 7 and z equal to 6 by 7. The minimum distance is d under root x square plus y square plus z square. Put value x, y and z in the equation. We get under root 504 divided by 7 is the answer of the minimum distance. Here some examples to do yourself. Thank you.